Let's wait. People are coming. Yeah, it popped up. So, hello everyone. How are you guys? I hope you all are doing fine. This is Rifat here, lead scientist and CTO of Space Kids India. Uh, Recently, the space traffic is really high for past few months, and in past 1 month, we are seeing a lot of launches, many launches towards the Mars. The traffic is really high. Many people are going towards the Mars. UAE launched it, China launched it, and now we have the Perseverance, scheduled to launch on 30th. So why people are marching towards Mars last year or before that? There were no launches to the Mars, but right now there are many launches happening. And why we are targeting Mars? So you may be having a lot of questions and you may be wondering. So today we are looking forward to answer those questions. We hope you will be able to at least solve some of your doubts and queries. You can drop your questions in the comment section as well. So today with us, our lead engineer, Mr. Abdul Kashif, is joining us, and also we have our lead technologist, Mr. Ignasai, joining us. So we are going to talk about Mars. So you might be, looking at the picture of Mars there, not that Mars, actual Mars, the planet Mars.
Not this Mars.
So
I was
over to
thinking it's this
Kashif.
Mars. You're not talking about this Mars. I was thinking it's this Mars and I prepared all my reports for this Mars. Man, I had to
I
redo my
wish we
work
are
now.
going to talk about this Mars. I wish we could talk about this Mars.
We shall come back to this Mars little later. Now let's talk about our
Yeah,
planet.
sure.
So why are we
Let's
targeting
see.
the Mars? The red planet. This is the planet which we know from pretty long time. We didn't need special satellites to see this planet, and hence this planet was known to mankind from like hundreds of years. And now we are going towards it. We are exploring it. But why are we doing it now? So before knowing that, let us talk about the planet itself, and then we'll slowly address why we are going towards it. So let's talk about Mars. We all know Mars is a small rocket. It's a small planet, and the diameter is half of that of Earth, and it looks red. That is why the name red planet. But why does it look red? It's because of the iron oxide. It's basically the rust on the surface. There's a lot of rust on the surface of the planet of Mars, and hence it looks red. And it has a thin atmosphere like that of Earth, uh, but the air is not breathable. There is a lot of carbon dioxide and less than 1% of oxygen. More than 90% is carbon dioxide, the thing which we omit. So it is not that good. And the temperatures we know, it is a very cold planet. Today's the temperature, the maximum is minus 6 degrees Celsius and the minimum is minus 69 degrees Celsius. So if you're going there, let's take our raincoat and our jackets and let's go there. And now we are targeting about Mars. The next to Mars is Jupiter, before that is Earth. It is the closest planet to Earth. We can go to Venus. Venus has a similar size of Earth. But no, we are going to Mars. There must be some reason. So let us talk step by step why we are going towards Mars. Why Mars? First thing, there are a lot of strategic, practical, and scientific reasons why we are going to Mars. Strategically, it shows as a humankind, a human species, how much we are evolving. It is not an easy task to go from one planet to other planet. Nowadays, people can't even go from one town to other town. People get confused even with the help of maps. Now, going to other planets is a whole other story. But we are trying. We went there already, and hopefully in future, even humans will step on Mars. So strategically, it will show how we are evolving, and this technology will not only help astronauts in the, or the space sector. The technology which is we are using in this, in near future, will help to humankind to prosper. And practically, going to Venus is not a good option. It is very hot over there. We will get black and then we will die before going over there. So what about Moon? Moon is nearby, but Moon has no atmosphere. Going there also won't yield us anything. But Mars is similar to Earth. I mean the size is small, The gravity is also 0.35 times of the Earth, which means you will jump high. But it has atmosphere. One good news. We found water in it. Other good news. And similarly, if we keep looking into it, we'll find a lot of other options. We have already found it, and we think life might have existed on Mars. We don't have any proof, but that is the reason we are looking for it. So, if we go far off Mars, across the asteroid belt, and then go to Jupiter, the way is far, like it is not feasible. Hence, we are looking for Mars. And one more thing, if you don't know, the Mars one day is 24 hours and few minutes, which is almost equal to Earth. So if a human goes over there, if he has enough to eat and enough to breathe, he will survive. It won't be that difficult. So that is why our aim is to go to Mars. Now let us see what are we going to do there. We are planning to go over there, but what are we looking for in the Mars? What do we have to know to decide if humans can go over there and humans can work over there? So what are we looking for? First thing we are looking for is the evolution of Earth, the evolution of Mars. When I say evolution, not the evolution of species, not the evolution of life, but the evolution of planet itself. Now we know that it has little atmosphere, but the surface is dead. Why, what do I mean by that? There is no tectonic plate movements, the volcanoes are dead, it is completely stagnant. But it was not like this before. It is slowly changing. So we want to know how it happened. How was it before? We see that the Great Canyons means there were rivers and lake before. What happened to them? Why did they disappear? So we need all these answers. Then only we can clearly understand what is happening to Mars and what we have to do. Now, once we know this, we should even know how is the climate changing with time. Now is a lot of carbon dioxide. Was it same before? Or did it change? If it changed, how did it change? Why did it change? All these questions has to be answered. And we can't answer it just by sitting from here. We can estimate little by seeing from telescopes, but sending probes, sending rovers, that is a whole other level. With that, we'll get the samples to test, and that is why a lot of people are planning and actually going and experimenting things on the Mars. Now, once we know about the planet, the next thing is did life actually existed in Mars before? Was there any life? If the life was there, was it same as how it is over here? Or the living organism concept was different over there? Would they used to eat, or how was it? It's a complete new story. We don't even know if the life still exists on it, maybe under the surface of the Mars. So all these things has to be known. And we humans, we are not the people who just sit. We always have this curiosity to know things. We want to know, are we alone or are we not alone? This is a big question. It is hunting us from like hundreds and hundreds of years. A lot of philosophers are talking about it. And now with this technology, I think we can know the answers. If it's not Mars, then we will go some other places. But the first step is to go to Mars. So now we are seeing a lot of things which is common between Earth and Mars, but we should even understand what is different between Earth and Mars, because there should be something different. That is why Mars is like that and Earth is like this. And with that understanding, we'll know how the evolution of the planets, the solar system, and the complete universe itself. We'll have a little better understanding of how this all happened. And the last thing, what we're looking for is the feasibility of humans to go there and survive, to go there and evolve, go there and make it as our second home. We don't want to go there as a visitor. We want to go there to settle. It should be our second place. And is that possible? We should know that. And how will we know that? We will not by sending the probes. We will get the enough information such that we can design the technology which we need for us to survive over there. We need to understand Mars enough such that we can do risk analysis, because lives matter more than anything. The cost is other big factor, but life is the biggest factor. So risk analysis is important. And we should understand their moons. They have two moons and we should know about it, what is happening. And not just this, we should know about the sustainability studies. And all this we are trying to do. We are slowly evolving and we are slowly trying to send ropes. And how are we getting the answers for this? We are getting the answers by sending the probes, by sending the satellites, by sending the rovers. So step by step, we are slowly evolving. We are slowly trying to conquer the Mars to learn and to evolve as a human species. Now, my friend Yagna and Rifat will share you how we are looking for the answers after going there. Over to you, people. You're on mute, Rifat.
Thank you. Thank you. Thank you. So yeah, you guys had a, I think, a better understanding about why we are going towards Mars. Kashif gave a beautiful overview. As of now, like whether we are looking at Blue Origin or SpaceX or any startup in the space industry, everybody is talking about Mars. So the initial step is to go there, put the robots, get the data, and be prepared for whatever, because when humans go there, whatever can happen. It's not going to be like Mark Watney shown in the Martian movie. That is a little bit exaggerated, because the density of the atmosphere is very thin that it cannot throw a person out like that, or something. But still, the soil, the atmosphere, everything is not suitable for humans to be there. We have to find more about that. So that is why back in late 1950s and 1960s, we know that USA and Russia were in Cold War. They started this exploration, exploration of Moon and Mars. So you don't believe that people used to believe that by end of 1960, no, by end of 1960s, they believed that people will be on the moon, and by end of 1980s, people believed that human will go and land on the moon, and they look forward to put a space colony in space by 2000. So you can go and search a movie. There is a movie called 2000 Mars or Space Odyssey, Space Odyssey. The problem happened is after 1969, the moon mission, the budget got significantly cut, and all the goals and all the plans we had, it got diluted. So let's see, like from where we started. Okay, so uh, Kashif, can you please go to the next slide? Thank you, thank you. So let me share you with what is Viking 1 and 2. Because whenever we talk about Viking 1 and 2, or like whenever we talk about the landers, these are the things first come in our mind. But Viking 1 and 2 is not exactly or not really the first thing to land on the moon. It was Russians who first landed on the Mars. But after landing, their lander only worked for around 6 minutes. So they didn't got any successful data out of it. So let me give you a small overview about the list of Mars missions, and like show you where we are standing today.
I mean, there were literally about 17 missions before the Viking, which got failed
Yeah,
in USSR and USA.
exactly. And Mars is the only planet where the success rate is only just 45%. It is very hard to go to Mars, reach the orbit, and doing landing and putting rover and all is next level. It's very tough. But the global average is like 45%. But recently, in the last launch window, 2 years back, two cube satellites went to Mars successfully. They did a flyby mission. They were called as Marco A and Marco B. This is the first time nano satellites are traveling beyond lower Earth orbit. Let me go show you guys where we started. So initially, we all believed that Russia is going to be the first one to put humans on
That's
the moon,
Sputnik.
because they are the one who sent the first satellite, first animals, then first humans to space, and they are the one uh, who first So they are the first one to the Luna 1 on the surface of the moon. So we all thought, they will be, going towards the Mars also first, and they did. So in 1960, in 10th October 1960, United States of Soviet Russia, USSR, launched the first artificial spacecraft towards the moon. It was a flyby mission. So first of all, let me clarify you what is the difference between a flyby mission, orbital mission, and landing mission. Flyby mission is something, you will reach the escape velocity from the Earth, and you will put your spacecraft in a trans-Mars injection orbit. It will be traveling in that trajectory. You will not slow down when you're reaching the Mars. You will not slow down the spacecraft. It will just fly past the Mars. It will take pictures of the Mars. It will be very short time, but it will collect enough data, transmit it back to Earth. It is a bit easier than capturing the orbit, because to capture the orbit, you have to rotate your spacecraft, reverse fire the engines to slow it down. You have to do a proper orbital insertion in the Martian orbit. So it is very tough, when comparing to the just a flyby. So all the initial missions were flyby missions, and there is a thing called impactor missions. What is impactor? Impactor means you will not slow down, achieve the orbit, and do a soft landing. It is like you will put your trajectory in such a way it will just directly go through the Mars. So you will not slow down or anything. It's like shooting a bullet out of Earth and towards the Mars. It will just go and hit the Mars. But in this process, we'll be very close to the Mars, so we can get the data. Even when we are going to the Mars, we will not
Hello, guys. I think there's a poor connectivity over there. So we were
Is my
talking
connection
about
working?
the. Yeah, it is fine now.
Yeah, I was talking about the next the orbital spacecraft. Orbital spacecrafts are like the traditional satellites. Instead of orbiting around the Earth, it will go to the Mars, and it will acquire orbit in the Mars, over the Mars, and it will be orbiting the Mars. So like our Mangalyaan, Mars Observer, Mars Reconnaissance Orbiter. All these things are orbiters. The recent launch of UAE, the Hope Mars mission, that is also an orbiter. It is a bit easier than landing on the surface. There are two more complicated stuffs called as lander and rover. So lander is, like you will do, like you will slow down from the orbital velocity of the, Martian orbital velocity, and then you will start the descent very slowly. But the problem is the atmosphere in Mars is very, very, the density is very, very less. For example, if you are in Earth, the atmosphere will help you to reduce the velocity. You just need to have the heat shield. Rest the atmosphere will help you. But in Martian surface, the atmosphere is very less that you need retro rockets to slow down. So it is complicated than landing on the Earth. You may be asking, because we are launching many space probes and we are landing it on the Earth. You may be asking, no, it should be same on the landing on the Mars, right? But it's not like that. It's very hard. So once you land, there are two types of spacecraft: landers and rovers. Landers means these are like spacecraft. It will have all the sensors and all the fancy payloads, but it won't have any wheels. It will just have 4 or 6 legs, depending upon the design. It will be a static payload. It will go, it will land. So that is why it is called as lander. It will collect a lot of payload data from the payload, and it will transmit. And the next one are the rovers, like the Curiosity rover, the Opportunity rover. These are more like vehicles, like our car, like a go kart or something. these things can move from one place to another place and collect a lot of data. So these are basically robots. And recently, in the upcoming Perseverance mission, first time we are going to have the an helicopter. We are going to have a helicopter which is going to fly and collect a lot of data for us. So over to Kashif, can you please tell me more about how this timeline was, or Igna, can you explain about what were the initial challenges Russians and Americans faced? So that would be interesting.
And yeah, as we mentioned, just there were about 17 launches before the actual Viking 1 and
Igna, we are
Viking
not
2.
able to hear you.
We can hear
Can you
you,
hear
bro.
me now?
Continue.
Oh,
Yes.
I think I'm not able to hear you.
Yes,
Yeah,
yes,
please
please
continue.
continue.
Yeah, like there were 17 launches which were failure before the Viking 1 and Viking 2. Each case is an, what I say, learning for and lesson for everybody, because initially there were only Russian satellites which were launching, as from 1957 you can see. 1960s they started to Mars, and there are a lot of missions like starting from 1960 there were two, and 1961 there were three. Continuously they had frequent launches. Then USA, they were advanced in technology, and they were actually trying to reach Mars before USA. So in those missions, you can see the failures. There were a lot of failures. I mean, like initial missions, they even couldn't reach, actually couldn't even lift off. And after then, a few even couldn't reach the Earth's orbit. And many of the satellites, even before USA getting to launch, they have failed like about 5 missions or something. So when USA actually started their missions, it was in 1962, I guess. The initial missions, even they had failures. Until 1975, there were literally about 17 missions, and literally everything was a failure. 1975, the Viking 1 and Viking 2 were the breakthrough for Mars exploration programs, which gave hopes to further missions, which are ultimate missions, as you can see about the rovers, Opportunity, Curiosity, all those stuff. Before that, like Rifat mentioned about what are orbiters and what are landers and rovers, we can see the first. Can anybody guess what was the first rover which has been to Mars? Any answers from the audience? Ash, we can go to the further slides after Viking. Yeah, the Pathfinder. It is a lander, but what is exact rover name? Anybody know?
Can I say? This lander is actually very famous in Martian movie.
Yeah,
This is what helps Mark Watney to contact the NASA back.
exactly. I mean, like looking at the launches, Rifat, every
Yeah.
launch of these rovers and orbiters is historical, and it really gives that goosebumps. All the space launches while landing, also the rovers. Have you seen the rover landing videos?
Yeah, yeah, yeah. Yeah.
The
And
Pathfinder,
JPL
and
is
even
very famous
the
for this.
Opportunity and Spirit.
Yeah.
Yeah, absolutely. The Pathfinder. Just tell the rover name, Rifat.
It was called Sojourner. So it is
Yeah,
actually one of the
such a
lightest lander ever landed, in an interplanetary planet, like on the moon or
yeah.
on the Mars, because we only been to moon and Mars, so we cannot say like ever. This is actually one of the lightest and cutest rover I have seen so far.
It was just about I think 1.8 kilograms or something.
Yeah, I think they are giving tough to our satellite technology, nano satellite technology.
Yeah,
JPL,
this gave hopes to other
it's very
rovers.
amazing that back in those days we didn't have fancy microcontrollers, fancy softwares and everything. But in that time itself, they were thinking about going to Mars, colonizing Mars and everything. That's amazing, right?
Absolutely, bro. In 1960s, that too. And their hopes were like literally from then. And 1970, how they succeeded with the first orbiter. And amazing, they started with this Pathfinder also in 90s.
Yeah, yeah. And we have to remember they did all this without Google. No internet, no knowledge sharing. emails,
And
sending,
yeah,
getting
one more
information.
example about the Pathfinder. Initially, when they launched, I think it was having some issues within 6 months or something. They had all systems reset, and they thought it is going to fail. And that actually was caused due to a software problem, which actually they have categories when they just let's take example that Pathfinder landed there and Sojourner have come out. So from Sojourner, obviously the data is going to Pathfinder, and from Pathfinder they're going to receive it. So the Pathfinder had system issues such as like it is full resets. So how did that happen was they had a protocols like what is the main criteria, major information to be sent to the Earth first, and then medium priority, and then lower priority. So these got clash, and the software obviously when it gets a lot of processing data into it because of the programming it got crashed, and later the same model what they had here on Earth, they tried to simulate all of those information and how what is the issue that causing the system reset, and later they found and they could actually upload the program and again reset it, and they solved the issue.
If
Yeah,
you
Earlier I
saw
was
yeah,
just
yeah.
talking
Martian,
about the
maybe you can
Pathfinder
relate
issue. Have
it.
you heard about?
If you saw Martian,
Sorry.
it is a clear example. In Martian, how they
Yeah,
repair
yeah,
it,
yeah.
it's a similar thing,
Yeah,
but actually
exactly.
happened in real life.
Exactly, exactly. And there's also one of the most face palm moment happened in space mission is the last ExoMars mission. It was a European and NASA collaboration where they, they got confused with Imperial and SI units. So during landing, USA people were giving in feet and inches, and these people are programming in centimeters and meters. So there was in algorithm, so there was a small unit conversion error which ended up in an overflow. So the descent rate was higher than they expected, and it just got crashed. So it's just like a very small like software error, not even a software error, an input error, like unit conversion error, and it ruined the whole mission. So Mars is like a lot of
Yes.
interesting things have happened.
And all these have inspired us, I can say that, right? And with all these things, we
Yeah,
have become
definitely.
stronger, we have become
Exactly.
better, and the perseverance is coming. And I think the new launch on 30th of July, and that will be something we have to look forward for.
Yeah. And actually, one more interesting point we should notice is like there is a major difference between all the other Mars spacecrafts and the Curiosity and Perseverance. And it is very hard to launch because it contains nuclear radioactive source inside it. So, if you know that all the Perseverance and previous launches, this Pathfinder and everything, these are powered by solar panels. But when you have a look at the MSL, Mars Science Laboratory, which is the official name, and we named it as Curiosity, that is a pet name we given. Like that, Perseverance is the pet name we have given. Official name is Mars 2020. In these two types of rovers, you cannot notice any solar panels. Because these are heavier than the previous rovers, it needs more power, and the solar panel has always been one of the most like the reason for the fiber. The lithium-ion batteries and solar panels have contributed to the shortage of the life mission duration. So these are powered by RTG, radioactive thermonuclear generator. What is that? In normal nuclear generators, like we have in the power
Nuclear
stations,
battery.
you will have a nuclear source. It will produce heat by like fusion, and that will heat water or some kind of source. It will create steam. We will move the turbine, and the turbine will create electricity. So this is a mechanical process, and space engineers don't like that much of mechanical things in that spacecraft because more mechanical movements can lead to the shortage of the lifetime. So in RTG, what we do is we will take the radioactive source. The same thing, the internal process is same. It will produce the heat, but instead of using the heat to produce a steam and doing a mechanical conversion, what we'll do is there is a thing called Peltier effect and seatback effect. In first standard or in the like first year, second year physics, you might have studied it. Seatback effect and Peltier effect. What we will do is we will it is a two type of junction between different kind of semiconductors. So basically, it is a material. It is like a pad. It looks like a pad. When you apply that over the RTG, it will convert the heat into electricity. And this electricity you can store and you can use it for all your space power system. It is not as simple as just putting a Peltier device. It is much, much complicated. But just for the example of how the RTG works, I tell you this. So it will give us like we don't need to worry about the Martian, the how to say because due to the wind, Martian soil got spilled all over the solar panels. Literally, that is one of the reasons why opportunity, like went natural. So curiosity and the perseverance, the case is totally different. As long as the other parts like computer, motor, and everything is working, it should just work fine. Even if the motors and wheels are getting ruptured, because the major difference between the Curiosity rover and Perseverance rover is the wheel design. They had some issues with Curiosity. The wheels got damaged sooner than they expected, so they changed it. But even if the wheels fail, still these two landers can work as a lander. It can work as a static landers because these have the nuclear power source. And since it is having nuclear source, it is very hard to launch it. You won't believe it will take twice or thrice the amount of effort to integrate it with rocket because the rocket itself is an explosive thing. It can just explode anytime. Just imagine you are putting a nuclear source on top of the rocket, and while it is traveling over some country or some place, due to some reason the rocket is getting disintegrated. All this nuclear waste just gets spilled over the atmosphere on all the places. So it is very dangerous. So how like what they do is they usually contain all the nuclear stuff inside a heavily protected container. There have been many incidents where the rockets carrying nuclear powered spacecrafts have been disintegrated and failed. There are a couple of satellites because New Horizon and Voyager is also powered by nuclear fuel only. There was a weather satellite which failed during the launch, but nothing happened to the RTG. The RTG just got separated. It was contained in a very heavy and very protected casing. It just, hit the ocean with very high velocity. Even at that point, nothing happened. It went inside the ocean. People went, they recovered the RTG, and they used it in the next mission. So that kind of protective technology they are having because the rocket failed, it fell back in the ocean. They went, recovered it, and used in the next mission. I think this is the first system to survive and get reused from a rocket failure. So it is very very tough. The Curiosity and Perseverance is very tough.
Yes. So we will be coming back live again for Perseverance, and I hope we'll
Yeah,
see you all at that time as well.
yeah. Can you switch to the next slide, please?
Yeah, sure.
Yeah. How much you like opportunity, bro? Like, what's your view and your emotions with the opportunity and spirit, Rover?
Bro, who can't like this, bro? Who can't like those people? Opportunity and all. It was emotional when the things came out in, I guess, last but 1 year, saying that
Yeah,
it is no more. The cloud came and it was losing its charge. It was all emotional. We
yeah,
didn't expect it to happen, and I think that is how we are connected to space. And little things that happen over there will. We actually didn't think it will exist for it will survive for this long time. It worked like long time. A lot of years it worked, which we didn't expect it. But even then, when it was going down, it made us emotional. And it
yeah,
will
yeah,
not only tell the technology point of view, but how emotionally we are connected to this technology and
yeah. To the missions.
it forward. Yeah. What about you,
Yeah,
Rifat?
it had a lifetime of around like just one Martian year, I guess. Yeah, yeah, few like very very less, like 90 souls or something. I'm not sure about it, but it worked for average like 9 years, I guess.
Yes.
That is something I always go, oh, wow, about the JPL. JPL builds one of the most reliable spacecrafts in the world. I just, you can literally go and reprogram the entire spacecraft. It is not like, normal nano satellites and small satellites. These bigger spacecrafts run on a real-time operating systems. You can take anything you want from the ground. I'm just thinking like the amount of programming and software undergone behind these missions, it's extraordinary. Whatever the error, whatever the problem, even if it is some kind of other mechanical or electronics error, they can fix it with the communication. So the amount of pre-planning and the amount of engineering they have did for these missions, it always amazes me.
True, bro. And I think that is what experience teaches. Like, if it was the first time, we wouldn't be this sure. And with every failure, with every success, cumulatively, we are learning and we are trying to make things better. And I think with this thing being like this, soon we will see humans stepping on Mars. And that will be
Yeah,
a
yeah.
milestone.
And I
And
want to ask you about the recent Hope mission. The Hope mission, universities played a major role with
yeah,
in collaboration. Like UAE went in collaboration with University of California and University of Colorado Boulder and Arizona State University. And the three universities and one space agency from other country, they built an entire 1,360 kilogram spacecraft, launched it, and put it towards the Mars. It amazes me that the power the academia has. So, what do you think about this, and when you are expecting these kind of things happening from India?
yes, first of all, the hope. I'm very proud of the mission. It was an amazing thing to see it launch, and I hope it will give beautiful results, which will help us do a little better in space sector. And speaking about the universities, I think the universities scientists will have a unique perspective, but for students, it is less about the experience; it's more about the enthusiasm to do something better, something new, something which will remember for a long time. That is what pushes the students to do that.
It will
And the
give them
universe,
something to look forward.
yeah, it will give them something to look forward, and that thing will actually help them grow, help them work hard for something. And that is a beautiful thing happening across various places, various universities. And Indians also, they're working. ISRO is helping them with small satellites. And I think eventually when ISRO grows, now we know that ISRO has taken some big decisions couple of weeks back, I guess. And I think ISRO is completely dedicating itself to R&D. And with that R&D effort, I think ISRO is going to do bigger missions, explore the space. And at that time, I think ISRO will give us, all the students around the India and maybe around the world, to help us do these missions and help us learn more and grow more.
Yeah, I'm just looking forward that day. Yeah. So there is a question from the comment section that uh,
What kind of
Mars.
microcontrollers and electronics
Yeah,
used for
not that
space?
one. Right now, there is a one I'm displaying on the. We will go by order. Krishna Kotkar is asking, what about Mars? He's asking when we are going to Mars, bro. What's your answer?
Hopefully, bro, soon, bro. That is our mission. We want to go to Mars. We want to conquer Mars. We will slowly,
Yeah,
we are working. Hopefully, we will tell about it when we are ready. We want
yeah,
to tell it when we are sure, and we want to, when we say it, we want to do it. With that kind of speed,
yeah,
we are working things.
yeah,
So we
yeah.
will tell you
And the same,
when we are ready.
yeah. And he is asking about like, but one doubt that how will they send big or heavy satellites to Mars outside the Earth's gravity belt? He is asking
Yeah,
about the escape velocity.
yeah, that is true. That is one of the biggest thing. The gravity of Earth is try thinking that is stopping us from evolving going forward, but that is not true. We are smarter than the Earth's gravity. Earth's gravity is fixed, but our technology, our intelligence is growing, and I think eventually we'll figure out new kind of propulsion systems which can make things easy, which can give us enough power to propel things in space. And we are looking for new technology. If we can't send a bigger item in space, What we are planning to do is send smaller items, put it in orbit, and then assemble smaller things over there, and then send it to the other planets or to the space. Even that kind of technology is being looked into. So I think we are working on it, and maybe in after some time, Earth's gravity will not be a biggest factor when considering mass and all.
Yeah. So the next question is, what kind of microcontrollers and electronics are used for space missions? Tarun, that is a nice question. I appreciate your question. Uh, the thing is, first I will tell about the lower Earth orbit in space, like in lower orbit what we use. We use traditional microcontrollers, like we use Atma microcontrollers. There are Cube satellite missions which carry PIC microcontrollers. Intel microcontrollers are there. Sorry, Intel microprocessors are there. Even in the SpaceX Falcon 9, they use x86 based microprocessors. But when we are going for Mars missions, moon missions, and all, we need to get outside the comfort zone because the lower Earth orbit is inside the Earth's magnetosphere. So we don't need to worry much about the radiation, like ionizing radiation. But when you're getting out of this magnetosphere and when you're crossing the Van Allen belts, where radiation is very intense, there are chances that these ionizing radiation can cause a thing effect called single event upsets and single event latch-ups. We know that computer works by zeros and ones. So there will be a lot of whole spaces inside the memory. Whether the electron is present inside, it is one. If it is not present inside, it is zero. What would happen is when you are going through the highly ionized environment, highly radiation environment, so these ionizing radiation can cause bit flip. The zero can become one and one can become zero, or all the zeros can become one and everything will become one. So it will just crash the computer and will cause it to reset, and it can stuck in an infinite loop of reset, making the whole mission a failure. So they use radiation hardened parts. One of the interesting factor is that both the curiosity and perseverance use a processor called RAD 750, which is based on Motorola PowerPC 750. The same processor which was used in Nintendo Switch, like not Nintendo, some game console. I forgot the exact name, but that processor was like same architecture they used in some game console a long time before, say like 20 years before, I guess. The clock speed is around 120 megahertz. So this kind of electronics is what we particularly use in Mars environment because even after landing, the environment may be bit better. But the 7 months to 1 year journey you're making from Earth to Mars is really harsh and hard. So your electronics needs to be very safe. So that is one interesting. There is one. Kashif, can you please go to next slide? Next one. We will go with the curiosity one. So the next one is there is a mission called the Phobos Grunt mission back in 2013, I guess. Yeah. I told about landers, rovers, and everything, but I forgot to tell you guys about the sample return missions. Sample return missions is like you will send a robotic lander. It will contain a small launch vehicle. It will go there. It will take some samples. It will pack it up inside the capsule, and that capsule will come back to Earth. So these kind of things have happened from Mars and Hayabusa mission from JAXA. We returned microscopic samples of asteroid. But this Phobos Grunt mission was a sample return mission. Two was Phobos. Phobos is a moon of the Mars. So they plan to land the lander on Phobos, take samples and come back. And it also contained a Chinese orbiter along with it. So they put it on top of the Frigate upper stage. Frigate is the upper stage of Soyuz and a few other launch vehicles. What happened is even before leaving the Earth orbit, some kind of problem happened, and these two missions failed to reach the trans-Mars injection. It didn't even escape the Earth's gravity. And the problem is one of the system got activated in the lander in the stage. It actually started pushing the payload back towards Earth, and within next few months, it just re-entered and got burned up in the atmosphere. So that was also caused by some of the errors happened in programming and electronics. Kashif, Yel Miranda is asking, she wants to know about Mars helicopter.
Yeah, so let me go about Mars helicopter. See, this Perseverance mission and Ingenuity, it is a little amazing thing. There's a lot to discuss about it. I was expecting my friend Yagna to speak more about it, but I think I will speak about it as his connectivity is very poor. So we are sending helicopter to moon, to Mars. That is something new to hear. But how? What is it going to do? We know that the things won't run same in Mars how it runs in Earth. Earth we have thick atmosphere, blades will rotate, and we will have lift generated and we are flying. A similar concept we are using, and we are sending a helicopter to Mars. Now the few things to remember is this is something which we are doing for the first time. On Moon there was no atmosphere, so sending helicopter made no sense. Now in Mars, this is something which we are demonstrating new technology, and I think this is something which we look forward to. We will get to know more about it. We will be speaking in detail about this thing in our Perseverance launch on 30. So maybe connect at that time, and we'll give you more insights about the missions, all the details. So I hope I'll see you then.
Sure, sure. I think we had a nice discussion today. I hope our viewers liked it. So, anything else, Mr. Kasha?
Yes, I think that is it. I think we help you understand little about why we are aiming towards Mars. And if you people have any doubts, you can ping to us, you can mail us, or you can put some comments in your comments, and we'll get back to you.
Yeah. So yeah, guys. So that's it for today's session. I hope you guys had an overview about what's happening with Mars and why the traffic is really high because this is the time the Earth and Mars is coming, very nearby. So the amount of energy required to reach the Mars is lesser in this period, and it happens once in 2 years. So that is why everybody is pushing this time. If it doesn't happen this time, then we have to wait for 2 more years. That is why one of the Russia and ESA collaborative Mars mission got postponed to 2022 due to a parachute error. So if the Curiosity is not able to get launched within in this month end or something, once the launch window is closed, because the launch window opens only for 2 months, then we have to wait for 2 more years. But I really hope sorry, not Curiosity, the Perseverance. I'm getting a little bit confused. So the Perseverance, we are planning to come live on that also. So just like our Facebook page and follow us on Twitter. We will be posting all our updates. Recently, we are planning to announce some competitions and one more cool announcement is coming very soon. So it will be helpful for you guys if you are following us on Twitter and Facebook. That is where we are going to publish major updates. So go to the Facebook Space Kids India. In Twitter also it is at Space Kids India, and subscribe and press the bell icon because we will be going live once in a week or two and discussing about a lot of new topics. If you guys want to join us, if you want to learn from us, you can go to www.skylabs.in where we are offering a 1 year junior diploma about electronics, computers, computer science, and space sciences, which will be helpful for you guys in developing nanosatellites and other things. All the links are given below in the description. You can go and check out. So thank you guys. Thank you so much. We're looking forward to see you guys in the next launch. See you. Bye.
Yeah, people. Thank you.
Thank you. Bye.